The National Electrical Code does not specifically address the installation and support of free air Belden cables for communication between programmable logic controllers, or PLCs. However, there are general guidelines that can be followed to ensure the proper installation and support of these cables. When it comes to installation, cables should be installed in a manner that minimizes the risk of damage. This may involve running the cables through conduit, cable trays, or other protective enclosures. Cables should be supported at regular intervals to prevent them from sagging or pulling away from their terminations. Support should be spaced no more than 4 feet apart for horizontal runs, and no more than 2 feet apart for vertical runs. Cables should be protected from environmental factors such as moisture, sunlight, and extreme temperatures. Regarding support, cables can be supported using a variety of methods, including cable ties, clamps, and hangers. Support should be strong enough to withstand the weight of the cables and any additional loads that may be imposed. Support should be placed at regular intervals to prevent the cables from sagging or pulling away from their terminations. There are some additional considerations to keep in mind. When installing free air Belden cables in outdoor applications, it is important to use cables that are rated for outdoor use. It is also important to follow the manufacturer's recommendations for installation and support. By following these general guidelines, you can help ensure the proper installation and support of free air Belden cables for communication between PLC. Selecting the right cable is also important. Belden offers a variety of cables suitable for different environments and applications. Ensure that the cable selected is appropriate for the specific installation conditions, including temperature, humidity, and exposure to chemicals or abrasion. The cable's voltage and current carrying capacity should also be considered to meet the requirements of the PLC system. Cable pathways are also crucial. Plan the cable routes carefully to minimize the risk of physical damage. Whenever possible, use existing cable trays, conduits, or other protective structures. If new pathways are needed, choose materials and construction methods that provide adequate protection and support. Avoid running cables through areas where they could be easily damaged by machinery, equipment, or personnel. Proper termination is also a critical aspect of cable installation. Use appropriate connectors and termination methods that are compatible with the cable type and the PLC input/output modules. Ensure that all connections are secure and properly insulated to prevent shorts or other electrical hazards. Follow the manufacturer's instructions for termination procedures to ensure reliable performance. Grounding and shielding are important for minimizing electrical noise and interference. Use shielded cables and properly ground the shields to the system ground. This helps to prevent electromagnetic interference, or EMI, from affecting the communication signals between the PLC. Ensure that the grounding system is properly designed and installed according to applicable electrical codes and standards. When routing cables, maintain adequate separation between power cables and communication cables to minimize the risk of interference. Avoid running communication cables parallel to power cables for long distances. If it is necessary to cross power cables, do so at a 90-degree angle to minimize inductive coupling. Surge protection is essential for protecting PLC and communication cables from voltage surges caused by lightning or other electrical disturbances. Install surge protection devices, or SPDs, at the input of the PLC and at other critical points in the communication network. Ensure that the SPD are properly sized and rated for the specific voltage and current requirements of the system. Cable identification is important for maintenance and troubleshooting. Label each cable at both ends with a unique identifier that corresponds to its function and destination. Use durable labels that are resistant to fading, abrasion, and chemicals. Maintain a detailed cable schedule that documents the location, function, and termination points of each cable. Regular inspection and maintenance are necessary to ensure the long-term reliability of the cable installation. Periodically inspect the cables, supports, and terminations for signs of damage, wear, or corrosion. Tighten loose connections, replace damaged cables, and repair any defects in the support system. Keep the cable pathways clean and free of debris to prevent damage and maintain proper ventilation. Documentation is critical for efficient maintenance and troubleshooting. Maintain accurate records of the cable installation, including cable schedules, wiring diagrams, and termination details. Document any changes or modifications to the cable system. Keep the documentation readily accessible to maintenance personnel. Training is essential for ensuring that personnel are qualified to install, maintain, and troubleshoot the cable system. Provide training on proper cable handling, termination techniques, and safety procedures. Ensure that personnel are familiar with the applicable electrical codes and standards. Continuous improvement is important for optimizing the cable installation and ensuring its long-term reliability. Regularly review the performance of the cable system and identify areas for improvement. Implement changes to the cable design, installation practices, or maintenance procedures to enhance performance and reduce the risk of failures. Consider using cable management software to help track and manage the cable system. Cable management software can help to automate tasks such as cable scheduling, documentation, and inventory control. This can improve efficiency and reduce the risk of errors. Testing and certification can provide assurance that the cable installation meets the required standards. Consider having the cable installation tested and certified by a qualified third party. This can help to identify any defects or deficiencies in the installation and ensure that it complies with applicable codes and standards. By following these best practices, you can help to ensure the proper installation, support, and maintenance of free air Belden cables for communication between PLC. This will improve the reliability and performance of the PLC system and reduce the risk of downtime. The principles of minimizing damage to the cables can be broken down into several key considerations. Firstly, physical protection is paramount. Cables should be shielded from potential impacts, abrasions, and crushing forces. This can be achieved by routing cables through conduits, cable trays, or other protective enclosures. The choice of enclosure should be based on the specific environmental conditions and the level of protection required. For example, in areas where cables are exposed to heavy machinery or foot traffic, rigid metal conduit may be necessary. Secondly, strain relief is crucial for preventing damage to cable terminations. Cables should be supported at regular intervals to prevent them from sagging or pulling away from their terminations. The spacing of support should be determined based on the cable's weight, diameter, and the environmental conditions. In general, support should be spaced no more than 4 feet apart for horizontal runs and no more than 2 feet apart for vertical runs. Thirdly, environmental protection is essential for preventing degradation of the cable's insulation and conductors. Cables should be protected from moisture, sunlight, extreme temperatures, and corrosive substances. In outdoor applications, use cables that are specifically rated for outdoor use and that are resistant to ultraviolet radiation or moisture. In industrial environments, use cables that are resistant to chemicals, oils, and other contaminants. Fourthly, proper bending radius is important for preventing damage to the cable's conductors and insulation. Cables should be bent in accordance with the manufacturer's recommendations. Exceeding the minimum bending radius can cause the cable to kink, crack, or otherwise become damaged. Fifthly, avoidance of sharp edges is necessary to prevent cuts and abrasions. Cables should be routed in a way that avoids contact with sharp edges, corners, or other abrasive surfaces. If it is not possible to avoid sharp edges, use protective sleeves or grommets to cushion the cable. Sixthly, proper handling during installation is key to minimizing damage. Cables should be handled carefully during installation to avoid kinking, twisting, or stretching. Avoid pulling cables through tight spaces or over sharp objects. Use cable pulling lubricant to reduce friction and prevent damage to the cable's jacket. The methods of providing support to cables also warrant a detailed examination. Firstly, cable ties are a versatile and cost-effective method of supporting cables. Cable ties can be used to bundle cables together, secure cables to supports, or suspend cables from overhead structures. Choose cable ties that are made of durable materials and that are resistant to ultraviolet radiation and chemicals. Secondly, clamps are another common method of supporting cables. Clamps can be used to secure cables to walls, ceilings, or other surfaces. Choose clamps that are sized appropriately for the cable's diameter and that are made of materials that are compatible with the cable's jacket. Thirdly, hangers are often used to suspend cables from overhead structures. Hangers can be used to support single cables or multiple cables. Choose hangers that are strong enough to withstand the weight of the cables and any additional loads that may be imposed. Fourthly, cable trays provide a continuous support system for cables. Cable trays can be used to support large numbers of cables in a neat and organized manner. Choose cable trays that are made of durable materials and that are sized appropriately for the cable's capacity. Fifthly, conduits provide a protective enclosure for cables. Conduits can be used to protect cables from physical damage, environmental factors, and electrical hazards. Choose conduits that are made of durable materials and that are sized appropriately for the cable's diameter. In addition to these general guidelines, it is also important to follow the manufacturer's recommendations for installation and support. The manufacturer's recommendations may provide specific information about the cable's bending radius, support spacing, and other installation requirements. Following the manufacturer's recommendations will help to ensure that the cable is installed correctly and that it will perform reliably over its intended lifespan. Choice of cable support method should be based on a variety of factors, including the cable's weight, diameter, the environmental conditions, and the aesthetic requirements of the installation. In general, it is best to use a combination of support methods to provide a secure and reliable installation. Furthermore, consider the specific environment where the cables are installed. In environments with high vibration, ensure that the supports are designed to dampen vibrations and prevent damage to the cables. In environments with extreme temperatures, use supports that are made of materials that are resistant to thermal expansion and contraction. In environments with corrosive substances, use supports that are made of materials that are resistant to corrosion. Remember that proper cable management is not just about aesthetics. It is also about safety and reliability. A well-managed cable system is easier to maintain, troubleshoot, and upgrade. It also reduces the risk of electrical hazards and equipment failures. Therefore, it is important to invest the time and effort necessary to ensure that a cable system is properly installed, supported, and maintained. When selecting cable ties, consider the tensile strength, material, and environmental resistance. For example, nylon cable ties are suitable for general-purpose applications, while stainless steel cable ties are more appropriate for harsh environments. Ensure that the cable ties are installed properly and tightened to the appropriate torque to prevent damage to the cable insulation. When using clamps, select clamps that are compatible with the cable's diameter and that provide adequate support without compressing the cable. Avoid over-tightening the clamps, as this can damage the cable insulation and reduce its lifespan. Consider using cushioned clamps to provide additional protection against vibration and abrasion. When installing hangers, ensure that they are securely attached to the supporting structure and that they are capable of withstanding the weight of the cables. Use appropriate hardware, such as bolts, screws, or anchors, to attach the hangers to the structure. Avoid using nails or other fasteners that may not provide adequate support. When designing cable tray systems, consider the cable fill capacity, load-bearing capacity, and accessibility for maintenance. Ensure that the cable tray is properly grounded to prevent electrical hazards. Use cable tray dividers to separate power cables from communication cables and minimize the risk of interference. When installing cables and conduits, use cable pulling lubricant to reduce friction and prevent damage to the cable insulation. Avoid exceeding the conduit's fill capacity, as this can make it difficult to pull cables and increase the risk of damage. Use conduit fittings that are compatible with the conduit type and that provide a secure and watertight connection. Besides the practical point of installation, there are also some safety precautions that need to be taken into consideration. Firstly, de-energize the circuit before working on any electrical cables. Always de-energize the circuit breaker or disconnect switch before working on any electrical cables. This will help to prevent electrical shock and other hazards. Secondly, wear appropriate personal protective equipment, or PPE. Wear appropriate PPE such as safety glasses, gloves, and a hard hat when working on electrical cables. This will help to protect you from potential injuries. Thirdly, use insulated tools. Use insulated tools when working on electrical cables. This will help to prevent electrical shock. Fourthly, avoid working in wet conditions. Avoid working on electrical cables in wet conditions. This will help to prevent electrical shock. Fifthly, follow lockout/tagout procedures. Follow lockout/tagout procedures when working on electrical cables. This will help to prevent accidental energization of the circuit.